All right, here we go. We're back. Thanks for your patience. So our goal for today, we're going to look at unit conversion in general, and specifically we're going to be looking at converting between degrees as a decimal, degrees, minutes, seconds, and then radians. Have you all heard of radians before? Radians are going to be super key in this semester. We're going to learn to think in radians instead of degrees. We're going to start that path today. We'll also look at some formulas for arc length and sector area. Those are pretty straightforward, just formulas, pretty cookie cutter math. And then I'm going to do my best to get you guys to really start thinking more in terms of radians than degrees. So unit conversion. The key to unit conversion is multiplying by a fancy 1. You've probably seen this in your math classes. Anybody in here do vet science? You guys do a ton of unit conversions in there. Ag mechanics and physics, awesome. So there's different ways to do this. If you have learned another way to do unit conversions, you're welcome to use it. I'm going to show you my favorite way. You guys know what I mean by a fancy 1, right? It's got to be something over the same thing. And it's 1. Now, what's going to be interesting about unit conversions for us is that something and the same thing might not have the same number, and they might not have the same unit, but they are going to be equal to one another. So, for example, if I made a fraction and I put 1 foot on the top, give me something I could put on the bottom that would be equal to 1 foot. I could put 12 inches down there. Give me something else that I could put down there. 12 inches is the obvious one. I'd say I could put 1/3 of a yard down there if I wanted to. But would you agree that 1 foot and 12 inches are the same thing? So that is a fancy 1. Even though the numbers aren't the same and the units aren't the same, it's still equal to 1 because we're dividing something by the same thing. All right? So our first example of the day, this will also serve as a public service announcement to you all, is we're going to convert 70 miles per hour into feet per second. So let me show you how I would go about this. So I'm going to start by creating a fraction out of my starting amount. I'm going to write this as 70 miles per 1 hour. That's what 70 miles per hour means, right? I'm going 70 miles every 1 hour. Our goal is to get to feet per second. So I'm going to multiply this fraction by some other fractions. And these other fractions, I want them all to be equal to 1. I don't want to change the thing that I'm looking at. I just want to change the units. All right, so let's deal with miles. I want to go from miles, and I want to try and get it into feet. All right, now, when I do not want miles in my final answer wants to be feet per second. So I need to get rid of these miles. We know that when we're multiplying fractions, we can cancel as long as we have the same thing in the top and bottom of a fraction. So if I want to cancel miles, I'm going to put miles on the bottom here. That's going to allow me to cancel these miles. And that's good, because my answer won't have miles in it. What can I convert miles into? Can I convert miles into feet? Yeah, we can. Can somebody give me some numbers that I can put into this fraction so that I have the same thing in the numerator and the denominator? 5,280 feet is the same as 1 mile. Now we'll look and see if there's anything that we can cancel, and there is. Now we look at the numbers and the units separately. I'm not canceling any numbers here. I'm canceling the unit miles and the unit miles. If I were to multiply out these two fractions right now, I would get an answer that would be in units of feet per hour. We're getting closer. We want feet per second. Is this looking familiar to you guys? All right, so feet is good. I'm going to leave the feet alone, and let's focus our attention now on hours. So let's find another fancy 1. Where do I want hours to go in this fancy 1, top or bottom? On the top in our numerator, because we want to cancel those. And Do you know hours to seconds? Why don't we do it in 2 steps? Let's go hours to minutes. Keep that in mind. We'll come back to that. And fill in some numbers to make those 2 pieces of the fraction equal to one another. 1 hour is the same as 60 minutes. And now I can cancel hours. If I were to multiply out these 3 fractions, my units currently would be in feet per minute. We're close. We need feet per second, so let's focus on getting rid of the minutes. So one more fraction, one more fancy one should do it. Where should I put minutes in my final fraction here? In the numerator so that it will cancel. And I can convert minutes to seconds. I just need some numbers in here so that those 2 quantities match. 1 minute is the same as 60 seconds. Now we can cancel minutes. And we now have the units that we want. All that's left are feet in second, which is what we want here. So we're going to reach for our calculators now. We're going to multiply out everything on the top and divide it by everything on the bottom. When you do this, multiply everything together on the top and then divide by, and make sure you use those parentheses. I usually don't type in the ones. So I'm going to go 70, parentheses, 70 times 5280 times 1 divided by 60 times 60. Oh, what did I forget? Parentheses, that is not going to come out well for me. Those parentheses, especially in the denominator, are super important. So I'm going to say that's about 103 feet per second. All right, so I told you this was going to be our first example, but also a public service announcement. Can anybody guess what my public service announcement is? Yes. Yes, those are great mathematical facts. But public service announcement is something that is in the interest of the public good, maybe outside of mathematics. So let me set up a situation for you. You're tooling down I-5 at 70 miles per hour, and song comes on your phone that's hooked up to your stereo that you don't like. So what are you going to do? You're going to skip it. How many seconds does it take you to skip a song? 1. How far are you going to travel while you're not looking at the road in that 1 second that you're not looking at the road? 103 feet. Now let's say your phone buzzes and you realize it's a text message from, I don't know, whoever sends you text messages. How long does it take you just to take your eyes off the road and read that text message? Let's say it's just a short, like one-liner. How many seconds would you say that is? 3 seconds? How far are you going to travel in those 3 seconds? 300 feet. That's the length of a football field that you just traveled down the road, like basically with your eyes closed. Okay? That's fast. That's fast. So this is my public service announcement to you. Do you all know that there's a function on your phone that will disable notifications when you're going fast, like when you're in a car? Turn it on. It's good for you. There's a setting that will even like automatically respond to people and say, "Hey, I can't answer right now. I'm driving." Right? Turn it on. It's the smart thing to do. All right, that's enough of that. Any questions about unit conversion? Yeah, so your smart thing to do is get your playlist set up ahead of time, right? There's this magical invention. It's actually been around a little while where they use the electromagnetic spectrum to send out music. Like it's like traveling through the air right now, and all you have to, there's like a little box. A lot of cars have it, where you can like set the frequency, and then you can like listen to the music that's already like in the air. It's like radio. That's it. Radio. There's also that thing. All right, let's keep it moving here. All right, so let's get into some other ways to talk about angles. We're used to, if I ask you to picture what one revolution looks like, you can picture what one revolution looks like, right? We're going all the way around the circle. How many degrees is that? 360. Most elementary students will be able to tell you that there's 360 degrees in one revolution. Now, I want you to keep this in mind, though. How big is a degree, a 1 degree angle? It's 1/360th of a revolution. That's pretty small angle. Like if you were to try to picture a 1 degree angle, like it's a pretty tiny. Okay, there are angles even smaller than that because a 1 degree angle can be split up into 60 minutes. And we use the degree symbol for degrees. Minutes is a single apostrophe. Kind of like a foot. Yeah. Yes. So 1 minute is 1/60th of a degree. I've got that down here. 1 minute is 1/60th of a degree. Now that's small. A 1 degree angle, if you try and picture a 1 degree angle, that's pretty tiny. Now cut that into 60 equal pieces. That's a 1 minute. All right, and it gets even finer than that because there's an angle called a second that is 1/60th of a minute. Mm-hmm. And it is based on time, and it has to do with navigation back in the olden days where they used. Yeah. So who would ever need a degree measure that was that detailed? Well, rocket scientists. It became pretty important when you're navigating across an ocean, 5,000 miles across an ocean. 1 degree is going to send you very far off course. So they would often use degrees and minutes. Seconds gets a lot more detailed. Yes, 60 minutes is the same as 1 degree. We're not talking time, though. We're talking angles.
You know how you have like those science experiments where they have the light and it reflects off of the different things, and you move the light a little bit,
and it goes, yeah.
It's kind of like that.
Yep. Yeah, a little tiny change here makes a huge change over here. Yes. All right. So, guys, stick with me here. So, double apostrophe, is that minutes or seconds? Shh. Seconds. So 1 second is 1/60th of a minute. And 1/60th of a minute would be how much of a degree? Coming back to that 3/600th of a degree. So when we're talking about a second, that is 1/3600th of a degree. So picture that 1 degree angle again, very, very tiny. Now cut it up into 3,600 pieces. That's what a second looks like. All right. Why do we teach this to you in high school pre-calculus? What a great question. Why? It's classic. It's classic trigonometry. Mr. Sweats, do you have a better answer than that?
Is it sexagesimal? Yeah. 60 based on 60?
Yeah.
We tip our hat to them, and they picked 60 because it's very divisible. Mm-hmm. Very easy to devise into nice fractions.
Yeah.
60 is a nice number. Quarter of an hour, half an hour, third of an hour, fifth of an hour, 10th of an hour.
6th of an hour, 12th of an hour, 15th of an hour. It's good. So many things go into it. All right. So guys, let's do an example here. Shh. So we've got an idea of how this works. Let me show you. This is relatively simple. If you've got your calculator, it's going to be pretty helpful to you here. We're going to convert 2 degrees, 31 minutes, 22 seconds into degrees as a decimal. Now, I want you to think about this for a second. Before we actually do the math, can anybody give me an estimate? Give me 1 decimal place. What is this going to turn into? It's going to be 2 point something, right? 2 point what? Why are you saying 2.5? 30 would be half of 60, right? This is about half of a degree. It's a little more than half of a degree, right? So it's going to be about 2.5-ish is what I'm guessing our final answer is going to be. We're going to round off to 3 decimal places. So here's what we're going to do. We're going to just do some fractions. We're going to say that's 2 whole degrees plus how many 60ths of a degree? 31 60ths of a degree plus 22 over 3,600. And then we just type that into our calculator. And we get our answer. And we guessed it was going to be about 2.5. Let's see how we did. Hey, we're totally around to 2.5. All right. Shh. Hey guys, we're gonna have to focus if we're gonna get through this and give you any time for assignment today. Let's keep moving here. Let's go the opposite direction. We're gonna go degrees, minutes, seconds. So our final answer, we're gonna want to write it as something degrees, something minutes, and something seconds. And this might end up having some decimals in it, but the other ones we want to keep as integer values. Can anybody guess what this first one's gonna be? How many whole degrees are we looking at here? That's 120. I know already this is going to be 120 degrees. And then some amount of minutes. Anybody want to make an educated guess about that? 0.26 of a degree. 0.26, that's about a quarter of a degree, right? How many minutes would be in a quarter of a degree? About 15. 15 is about a quarter of 60. So I'd say this is probably going to be like 15, maybe 16 because it's a little bit more. No idea what that's going to end up being. We'll have to do a little bit of math to get there. All right, so here's how I kind of work through this process. I'm going to say that this is 120 degrees plus 0.265 degrees. Now, if I want to turn this into minutes, I can accomplish that by multiplying it by how many minutes are there in a degree. 60. All right, reach for that calculator and do that math. 0.265 times 60 is 15.9 minutes. That's 15 whole minutes, which is what we guessed, plus some extra stuff. That extra stuff we're going to turn into decimals. So that is 15 whole minutes plus 0.9. And if I want to turn that 0.9 minutes into seconds, look what I multiply 0.9 by. 60, because there's 60 seconds in a minute. So 0.9 times 60 is, hopefully we don't need a calculator for that. What's 9 times 6? 54. Do you think it's 54 or do you think it's 5.4? 0.9 times 60? 54. On the dot. All right. So you're going to have several problems in your assignment where you're going to be converting between these two things. Just come back to these examples, follow that same. This is pretty cookie cutter, step-by-step math. Any questions before we move on? Yep.
So why is it when you're doing conversion from degrees, seconds, minutes to the decimal, or the minutes, seconds into the decimal?
Yep.
Why is it over like the seconds? Why is it over 3,600? But in the decimal, it's the degree.
Great question. So why are we using 3600 here, but we're only using 60 here? Is that your question? That does seem like a bit of a disconnect.
Because we've already multiplied it.
It's exactly it. Because we've already multiplied by 60 here, so there's your 3600, that 60 and that 60 combined. Another way to think of this as this conversion is all happening from degrees into, or from minutes, seconds, everything is going into degrees. So we need to use the ratio of 1 to 3600 to get from seconds into degrees. When I'm doing this conversion right here, I'm going from minutes into seconds. That ratio is 1 over 60. So a couple ways to think about it. Excellent question. Thank you for that. What other questions do you guys have? All right, let's keep moving. You're doing great. Oh, we're not even halfway done. Radians. All right, now, if you know the punchline to this joke, please refrain from spoiling it for the rest of the folks who may have not seen this joke. You can set your pencils down for a minute and just relax. There is a thing called a radian, and I've told you that I'm going to want you to start thinking in terms of radians, so I want to give you sort of a visual representation of how this works. And we are going to sketch this in our notes in a second. But for right now, just relax, enjoy the show. All right, I've got here a radian. I've measured this out, and this is equal to 1 radian. Okay, but I want you to know what the definition of a radian is. So here's the definition of a radian. If I take a length that is equal to a circle's radius, okay, and I kind of curve it a little bit, and I wrap it around the outside edge of the circle, that angle that it makes gives me 1 radian. That's why it's called a radian, because it's the radius that determines how far along the edge of the circle it takes to get a radian. That's what 1 radian is defined as. Okay? Now, I've got several other radii cut out here. And again, if you know the punchline to this, keep it to yourself. I am going to take, and I'm going to start wrapping some more radii around my circle here. Okay? And my question to you is, what is your best guess? How many of these radii do you think it's going to take me to get halfway around the circle? Now, to get halfway around. Nope, that's the punchline. Keep it to yourself if you know. So I've heard some guesses. Let's start doing it. This will take me a second. Fine motor skills, guys. All right, here is 2. No, it's just string. It's bendy string. It's just string. It's kite string. There's 2, and you guys said 3. And you're pretty close, but we're a little bit shy. 3 point something. 3 point, oh, there's the punchline. 3 point what? 3.1459, otherwise known as pi. Now, if I wanted to go all the way around, it's going to take me a little bit more than 6, about 6.28, which is 2 pi. So here's what I need you to know, okay?
This made it make sense. I didn't.
All right, that's awesome. It worked for you. All right, guys, so here's the key to our success here. Shh. I need you to know that a radian is defined as the angle where 2 pi radians get you all the way around the circle. So 360 degrees would be the same measure as 2 pi radians. If you wanted to kind of draw yourself a representation of what we just talked about, you could draw the circle, and we could talk about stretching some copies of R around it, and that third copy we saw didn't quite get us halfway around the circle. We've got 1 radian, 2 radians, 3 radians, plus a little tiny portion of it. That's the 0.14, so on and so forth in our pi. Common question at this point in the semester is, why do we have to worry about this? We understand degrees. Degrees works fine for us. Why do we have to do radians? Well, it turns out that a lot of stuff in math works a lot better and simpler when we deal with angles and radians. I want you to think about the formula. Well, I'm going to pause and let you guys get caught up here. I want you to try and make a connection here as you get caught up. And I want you to think about the formula for the circumference of a circle and how it relates to what we just talked about. I want you to think about the connection between what we just talked about here, how pi radians gets us halfway around the circle and 2 pi radians gets us all the way around the circle. And I want you to think about what you learned back in geometry and probably even before that about the circumference of a circle. Do you guys remember the formula for the circumference of a circle? We really should at this point. It is 2 pi r. What's the connection here? Yeah, so 2 pi, we said 2 pi radians would get you all the way around the circle. And the circumference is the distance all the way around the circle. Circumference is the distance around the outside edge. All right, so let's practice a little bit. We're going to step back from the kind of big picture conceptual idea of a radian. Let's practice just doing some unit conversion. So we're going back to our fancy ones here. I want to convert 60 degrees into radians. So what I'm going to do is I'm going to start with 60 degrees. And it's not degrees per anything, so I'm just going to put a 1 on the bottom of my first fraction. And all I need to do is multiply it by some fancy version of 1 to cancel out the units I don't want and turn it into the units I do want. I don't want degrees. Where am I going to put degrees in my fancy 1? Degrees in the bottom. And we can convert now degrees into radians. And we got options here. We need to make these two things equal to one another. We could go with 360 and 2 pi, but is there a simpler way? 180 and pi is going to be your simpler way. That's the most reduced fraction. So I know that 180 degrees is the same as pi radians. Now that I'm convinced that this fraction is equal to 1, I can go ahead and cancel my units. Do a little bit of multiplying. We are not going to use the calculator for this. I want exact values. And just to reiterate, there was some confusion about this on our last test. Exact values are not decimals. They're not rounded decimals. If you are punching a number into a calculator, seeing a decimal answer and rounding it off, that is not an exact value. An exact value is a fraction or a radical or a fraction in terms of pi like this. This is an exact value, but there's a simpler version of this. 60 over 180 does simplify. That would be 1 pi over 3. Both of those are divisible by 60. And I did not write my units in here. I can if I want to. But it turns out that radians are a unitless measure. I don't want to get into what that means exactly right now. But what it means to you is you do not have to write radians next to a radian answer. If I ever see an angle and it doesn't have a unit next to it, I will assume that you're talking about radians. Okay. If you write radians, that's fine. You don't have to. For example, here, I did not tell you what 5 pi over 6 was, but you can infer from the context of the question that it is an angle. And since I did not put a unit there, what can you infer the unit is? It's radians. If it's an angle and there's no unit given, you assume that it is in radians. So we'll do our unit conversion. We'll use our fancy 1 to convert this as well. So I'm going to start you off here, 5 pi over 6. When you have a quantity that is already a fraction, your unit goes in the numerator. So 5 pi radians over 6. See if you can find me a fancy one that will cancel those radians and get us into degrees. This time you could use a decimal if you need to. So again, we want to use the simplest conversion ratio. Let's stick with 180 and pi. I want to cancel radians, so I want radians down here. We'll get degrees going up here. How can I make this equal to 1? The simplest way is 180 and pi. Radians cancel. Now we're in degrees. And the beautiful thing about this one is that the pi is also cancel. 5 times 180 over 6. Can you guys do that in your head? Do the 180, divide it by 6, and then multiply it by 5. 180 divided by 6 is 30 times 5 is 150. Or use your calculator if you don't feel up to the mental math today. 5 times 180 over 6. All right, now, do you have to set up these fancy ones every time you're doing these unit conversions? My answer is no. There's a shortcut. If you're going from degrees to radians, you're always going to multiply by pi over 180. And when you're going the other way, you're going to always multiply by 180 over pi. I'm not a big fan of that myself because I tend to flip things if I'm not careful, right? So if there's a rule where like half the time you do it this way and half the time you do it this way, about half the time I'm going to do it the wrong way. So I like to have a nice system in place to remind myself, and this fancy one method never fails me. If I ever get confused, I'm like, which way was it, 180 over pi or pi over 180? Just set up your ratios, figure out what your fancy one is, and that'll get you out of that quandary. Questions? All right, we're almost there. We are 60% of the way there. All right, this is the simplest part of the lesson today, arc length. So we talked about circumference a moment ago. Arc length is just a portion of the circumference. An arc length is the length of an arc, and an arc is just a portion of the circle. If we're talking about a piece of pizza, the arc length would be the length of what? The crust. Arc length is the crust. There are two different formulas for arc length depending on whether your angle is in degrees or radians. Yes? Well, it is proportional to the radius because it has r in the formula. You're absolutely right. It is proportional to radius. But I need you to know what the definition of an arc length is. And the arc length is the arc is the portion of the circle. The arc length is that distance around the edge of the circle. So if we were talking about a 360 degree angle, the arc length would be the same as the, give me a good geometry vocabulary term. I'm going to say the question one more time. Fill in the blank. If we were talking about a 360 degree angle, then the arc length would be the same as the circumference. Okay, this is just a portion of the circumference. I'm not a big formula collector. I've told you guys before I struggle with memorizing things. So when I learned this, I only bothered with this first one because it's simple and it's easy to memorize, and I know how to convert between degrees and radians. So if I ever got a problem that was in degrees, I would just convert the degrees to radians and I would use this formula. I didn't try to learn this formula as well. It really does. When you convert from radians to degrees, you multiply by pi over 180. So the conversion is just built into this formula. All right, so we'll do an example. We'll use the formula here. This particular problem is in degrees. So go ahead and draw yourself this little wedge here, 75-degree wedge. Our radius is 30 feet. And since we're in degrees, we could use the degrees formula here. Should be S equals, and then I just need to get some numbers in here. Pi, I'm going to need an R, I'm going to need a theta, and 180 is built into it. Are you guys familiar with theta? You remember theta from geometry? It popped up a bunch. We're okay with the Greek letters. We often use Greek letters to represent angles. So we'll be using alpha and beta, gamma, the Greek alphabet. First letter of the Greek alphabet is, last one? Omega. Alpha, beta, gamma. That's as far as I know. I know gamma's or omega's at the end. All right, so R comes next, is 30. Theta is 75. And if we wanted a decimal value, I would just type that into the calculator. If I want an exact value, then I would want to simplify my fraction. You know what's wonderful the thing about these calculators, though, is they'll simplify fractions for you. You guys know that, right? If I were going to do this as an exact value, here's what I'd type in my calculator. I'd go 30 times 75 divided by 180, math frac. Oops, that's not what I wanted. Math frac. I'm just putting this portion into my calculator, leaving the pi out. And then I'm going to stick the pi on the end. So my final answer is 25 pi over 2. Give me some units here. We're measuring a length. In the context of this problem, what is the length unit? Feet. So 35 pi over 2 feet. If I wanted a decimal approximation, I would type that in. 25 pi over 2 comes out to about 39.3. Does that seem reasonable? All right, here's a pizza problem for you. I know, right before lunch, huh? 14-inch pizza cut in 6 slices. How long is the crust on each slice? There's other ways we could do this problem. Back in geometry, if you didn't know about arc length, how would you solve this problem? 14-inch diameter, yeah. So you would figure out, back in geometry, you probably would have figured out what the circumference of the whole pizza was and cut it into 6 equal slices. But let's do it the pre-calc way. I'm going to make a sketch of my pizza here. 6 slices. Question? 14 inches is the diameter. In pizza technology, when they give a inch or whatever they're talking about all the way across the pizza, which means our radius is 7. Now, guys, we're trying to find the length of one of these slices, just the crust. Let's do this one in radians, okay? I want you to start thinking in radians. If I took 3 of these slices, that would be half of my pizza, agreed? What is the angle for 3 slices? What is half of a circle? In radians, what is half of a circle? Half of the circle is pi, but we're only doing 1/3 of pi, so my angle is pi over 3. That would be my angle in radians. Now, I can figure out what it is in degrees. How many degrees would it be? 180 divided by 3 is 60. We could use 60 degrees for these, but if we can do it in radians, this formula becomes way simpler because it's just S equals R, which is 7, times theta, which is pi over 3, I think that's just 7 pi over 3 inches. All right. Moving forward, never pass up the opportunity to think in radians instead of degrees. That'll be the last thing we do today. I'm going to share one last thing with you. This is not actually in our textbook, but it is a concept that is typically taught in pre-calc. For those of you who are doing CWU, you'll probably want to have these formulas. Yep, I'm sorry. Moving too fast. I can zoom out so we can see both. I want you to get these into your notes. Those of you especially doing CWU, we're not going to do any examples on this. It's just a formula. Okay, this is sector area instead. So this is no longer the crust. This is the cheese and toppings. All right, so take a moment and get those down. And then we're going to just do a little mental exercise in thinking in radians. In this unit, or in this semester, I should say, it's not just this unit. We'll spread it out over the first couple of units. You have the opportunity to earn actual bonus points this semester. Not an optional project like the Poly project, but legit bonus points, points that would get added on to your test score. Okay. There are 12 bonus points. Is that right? I think there's 12 bonus points available. 12 bonus points means you could get an 88 on one of your tests and it would turn into 100%. Right? 12 bonus points could mean you get a 90 on all 3 of your unit tests, and you get to add 4 points onto each of them. You get now those A minuses are an A for all 3 of your tests. That can make a difference. Okay, and I'll tell you what the first 2. So they're memorization quizzes. There's 6 of them. The first 2 are going to be converting between degrees and radians and degrees. Okay. And so, for example, in the first one, I might give you the angle 2 pi over 3. And I need you, and these will be timed. So within a couple seconds, I say 2 pi over 3, you need to be able to say how many degrees is that? 2 pi over 3 would be 120 degrees. If I say 11 pi over 6, you need to be able to say 330 degrees. Okay? So you're going to have to do them pretty quickly. And then the second one will be the reverse of that. I'll give you 270 degrees, and relatively quickly, you need to be able to turn that into 270 degrees, 3 pi over 2. Okay? And then the rest of them are going to be with sine, cosine, and tangent, which we'll get into later on. So in the interest of kind of moving us in that direction, I just want to do like a little mental exercise. This really kind of helped me learn to do the conversions, and we'll practice this a little bit too. By the way, I'll be posting some practice quizzes for these so you can use them to kind of time yourself in practice. Ooh, I need to not blow away my thing. So here's what we're going to do next. This is the... We're not getting into any major new concepts here. My goal here is to kind of give you a trick or a way that you can visualize how degrees and radians relate to one another. So the angles that I'm going to ask you to measure or to be able to convert between in these memorization quizzes will be all of the angles on the unit circle, so from 0 to 360, that are multiples of 30, 45, and 60. I guess 30 and 45 would be sufficient, wouldn't it? Because anything that's a multiple of 30 is going to be a multiple of 60, yeah. But I tend to split them up into 180, 90, 60, 45, and 30. And I'll kind of show you what my thought process is here. So I'll give you a minute to draw these 5 circles. So it sounded like many of you had some exposure to the unit circle last year. Are you used to thinking of a 0-degree angle having the position of the positive x-axis? Is that something that's familiar to you? We're going to be getting into that in the next lesson. So that's convention. Somebody decided a long time ago that that's how we were going to do it. And that's how we do it. So when we're talking about a position around a circle, 0 degrees is usually going to be on the positive x-axis. That changes if we get into navigation. And navigation, 0 degrees is due north. On the unit circle, 0 degrees is to the right. All right, so this is kind of a visual representation of converting between degrees and radians is what I'm trying to get at here. Some people are still drawing circles, so I'm pausing for a second. I don't want to leave anybody behind here. All right, give you the universal sign if you need another minute to get prepared. Are we ready to go here? All right, let's do this. Okay. What do we know? We already know that 180 degrees is pi, right? And that it is halfway around the circle. So if I started at 0 here, could I get you guys to look up here and just follow me, and then I'll give you a moment to write it down. Don't worry about trying to copy as we go, okay? I'll pause in between. So here's my visual representation. I'm at 0, and I'm going to travel 1 pi around my circle. That's going to get me halfway around. Don't draw it just yet. This is pi, which is 180 degrees. Now, if I do another pi, this was 1 pi. This would be 2 pi. We're just counting. All right, draw those on there. So pi is halfway around the circle. That's kind of the key piece. All right. Let's think in terms of degrees, and let's do multiples of 90. 90 is a quarter of the way around the circle, right? So here's 90. And then if I add another 90 onto that, that gets me to 180. And another 90 onto that, that gets me to 270. And another 90 onto that gets me back where I started, which we think of as 360. So there's my degrees. We're going to now think of this in radians. So again, please just watch, and then I'll give you a moment to draw it. Are you ready? 90 degrees is how many radians? It's half of a half circle. So pi over 2. All right, so watch me. I'm going to count. Here is 1 pi over 2. Here is 2 pi over 2. Here is 3 pi over 2. Here is 4 pi over 2. Now, I would never write 2 pi over 2. 2 pi over 2 is just pi. And I would never write 4 pi over 2. That's 2 pi. We've already got those on here. So some of these are going to simplify. But it really is just a counting game. You're just counting around the circle. All right, so we're going to 45s now. So let's chop this up into 45s. So I'm going to chop it into 90s, and then I'm going to chop those 90s in half. And let's go around and write our degrees around the circle. So 45 plus another 45 is 90, plus another 45 is 135. These angles are going to become like ingrained in your mind over the course of the next couple months. Plus another 45 is 180, plus another 45 is 225, plus another 45 is 270, plus another 45 is 315, and then one more gets us back to 360. So when we're counting in degrees, we're counting by 45s. We're going to count now in radians, and we know that 45 is half of 90. 90 is pi over 2. What's half of pi over 2? Pi over 4. All right. Do you guys remember the count from Sesame Street? No? He counted things. He was a vampire. It's actually based on... Did you know that's based on an actual folklore that they had to count things because like there was like this like one of the ways that you could get away from a vampire was to like take a jar of nails and throw it on the floor because they had to compulsively count everything. So they would have to sit there and count all the things before they could chase you. It's folklore. Anyways, Sesame Street somehow folded that into a children's show. But he was the guy that he counted and he'd go like, 1 pencil, 2 pencils, no? Okay. Anyways, we're going to count in radians. All right, are you ready? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Sorry. That's what I always think of when I'm doing this. Someone's going to be taking the test and they're going to be going, You guys remember that? I don't know. Sesame Street, it's like it changes over time. So like some of the things that I remember from Sesame Street, like they don't do anymore. All right, questions? Yes. Shh. Quiet, please. We'll get into positive and negative angles next time. Just a preview of next class. Positive angles go counterclockwise, negative angles go clockwise. But that's next class. Don't worry about that for now. All right, let's do 60s. Now, 60s are a third of a full circle. So this time, cut your pizza in half and cut that half into, 60s are a third of a half circle. So cut your pizza in half and cut that half into thirds. And that'll get you 6 equal pieces here. And we can count by 60s. This is a little bit easier than the 45s. 0, 60, 120, 180, 240, 300, and 360. That's in degrees. We're used to thinking in degrees. That's going to be a little bit easier for us for now until we start thinking in terms of radians. When we're counting in radians, 60 is the same as pi over what? There's 3 pieces in my half circle, pi over 3. So we'll go 1 pi over 3, 2 pi over 3, 3 pi over 3, aka pi, 4 pi over 3, 5 pi over 3, and 6 pi over 3. Kind of wish I hadn't told you that. That's all right. Why not? It's fun. All right. All right, last one. 30 degrees. When I do 30s, I cut it into quarters first. And then I cut each of my quarters into 3 pieces. Now this gets pretty dense here. I kind of wish I'd made this circle a little bit bigger. We're going to have a hard time with this one. But I'll give you a little hint about the 30s. Okay, and I'm going to give you some other hints that are going to make this a little easier too. I'll give you a hint about the 30s. There's only 4 angles that you really need to worry about with multiples of 30 because we've already covered everything else in the unit circle. The ones that you're going to need are, I'll highlight them here, are this one, this one, this one, and this one. Those 4. Because we've already done the rest of this. We did 60 and 120. We did 90 and 180. We did 240 and 300. We did 270. Those are the only new ones that we need to count. So what would those 4 be? I'm only going to actually label these 4. This one's 30. Now this one's 30 short of 180. It's a little bit less than 180. 30 less than 180 is 150. This one's 30 more than 180, 210. And this one's 30 less than 360, 330. And I'm going to count all the way around, but I'm only going to write my numbers in for those 4. So 30 is pi over 6. So we got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 6, that does look like a 0, sorry. 6 pi over 6, 7 pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Now, eventually, if you guys do your part and you want to make your life easy this semester, you are going to practice this until you can kind of spit it out pretty quickly. So I'll kind of walk through how I would do it. So somebody give me one of those angles in degrees. 210, sounds great. 210. 210, is that divisible by 30, 60, or 45? 30, 210 is 30 times what? 30 times 7. All right, so that is 7 pi over, what was 30 again? 30 was pi over 6, right? 7 pi over 6. Here's another one. What about 300 degrees? 300 degrees divisible by 30, 60, or 45? What's the biggest one that's divisible? 60. 300 is 60 times 5, right? 60 times 5 is 300. Okay, well, if you can remember that 60 is pi over 3, that's just 5. And 60 is pi over 3, 5 pi over 3. All right, going the other way is actually easier. If I gave you 11 pi over 6, you're going to sit and you're going to think, okay, what's the pi over 6 again? Pi over 6 was 30. Oh, that's just 11 times 30. That's 330. Or if I said, help me out with 4 pi over 3. 4 pi over 3. I'm going to look at that. I'm going to say, pi over 3. What was pi over 3 again? Pi over 3 was 60. Oh, that's just 4 times 60. 240. All right. These are different ways of thinking through. Some of you are going to really make this sort of a visual thing. You're going to be picturing those slices of pie and probably counting like the count as you go around. Some of you are going to kind of think about in terms of multiplying like this. And some of you are just going to straight up memorize it. For those that can do that, I envy you. I always have some students that they can just memorize stuff. That is not my strong suit. But we want to get to the point where we can freely convert any of these angles that we've talked about. Okay? Now, do you need to do that before next Monday when we have class again? No, absolutely not. Okay? Our first memorization quiz will not be next week. It'll be the week after that. I'll give you a firmer date as next week. Okay? Some of you might already be there. I can show you, if you are interested, what the practice quizzes will look like. Let me stop my recording here, and I will do that.